You have one new title to add today, and we are finished with this unit.
Oh no, I'm there, I'm there.
Okay, while you're getting your title page up, I need homework that was due today. Some of you have already turned it in. I have a couple that still need to turn theirs in on congruent figures. One on the congruent figures that you worked on, right?
Yeah, that's right. Right there, it's like, we use that 83 4 already.
Huh?
On there, it's like congruent parts.
Yeah, we've done all this.
But on the warm-up, it says page 83 and 84. On the other thing.
Uh-oh. What? Uh-oh. I see what you mean. Cause I should say 69 and 70. That's why Anna was so confused. This should say 69 and 70.
That's why everyone had the wrong page.
What page did you do? She was already getting 70.
I apparently did not edit it from last semester.
You were so small.
Because I use the same slides every semester, I just edit because I change the pages and stuff up. That's why you were so confused. Now we're good. So that should have been on 69 and 70, Anna.
Yeah, I did. What? It made more sense.
Okay. Travis, do your homework. You weren't here Friday.
Miss Beth, can I see the homework? Is
No,
this
I
one
already have
homework?
yours. You turned yours in Friday before you left.
Is this
You
one
got
homework?
Yes.
Oh, this is gonna be easy.
Again, please, 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 do not forget about your project due on Friday or next Friday. It's 50% of your grade. It's like going in as a test grade. Okay. So, Friday we talked about similar figures and the fact that similar figures are the same shape as well as the same size. Okay. So, congruent figures are same shape, same size. What are similar figures? What does it mean for a figure to be similar? No, the same is congruent.
Alike?
Okay, they're alike. They're alike in what aspect?
Their shape?
Their shape is the same. Good. What is not the same?
Oh, their size?
Their angles are still the same. Their size is not. Okay? So, take a look at my darling baby girl. She's cute. Okay? These two pictures are similar. It looks like Riley, but one's smaller, one's bigger. So that's what we're talking about in similar figures. So, similar figures, explain what it means to be. They are the same shape.
They look the same.
So they look the same,
But size.
but different sizes. They look the same, but they're different sizes. Number 2 says, draw an example of two figures that are similar. Okay, so here is a right triangle. Here is another right triangle. Both right triangles, both the same shape. They both look the same, but one is bigger than the other. And the bottom part says, draw an example of two non-similar figures.
You can draw two shapes that are the same.
You could draw a circle and a square. They're not the same shape. Nothing about them is similar. What was the transformation that we learned in Unit 1 that would produce similar figures? What transformation made shapes bigger or smaller?
Ooh.
No. Friday we talked about congruent figures were rotation, reflection, and translation. There was one more that we talked about that would produce
Dilation.
Dilation. Dilation makes things bigger or smaller. Okay. So we can prove that two triangles are similar by creating ratios. Okay, so this triangle has a ratio of 2 to 1. This other triangle, notice where I pulled the 2 from. I pulled it from the side of the triangle, so I need to pull the number from the side of the triangle first. So this one has a ratio of 3 to 1.5. Okay, I went side bottom, so when I do this second fraction, I have to do side bottom. This is a proportion when there's two fractions and an equal sign in between. How do I solve proportion? Think about it. Thanks, Miss Susan. Okay, when I have a fraction across an equal sign, how do I solve?
What was the question?
Don't you cross multiply?
Cross multiply, perfect. Okay, so when I cross multiply, 2 times 1.5 is 3 equals 1 times 3, which is 3. As long as these two equal, your triangles are similar.
So if they're the same number, they're equal. But they're not the same number,
Then they're not similar figures. Okay, think about a map. A map is just a smaller version of North Carolina or Pennsylvania or the world. Okay, it's scaled down. It's a scale factor. That's what you've created here as a scale factor. Okay, something else about similar figures. Similar figures' angles are exactly the same. They do not change. So we need to find the measurements of X, Y, and Z. If this angle is 28, what is angle X?
28.
Same.
Y.
It's across from
It's across from it. So what kind of angles are these?
Okay.
It's across the V.
2 equals y. Y equals
We're not talking about Y. I want to know why these two are equal.
Isn't it that one's greater than 0 or?
There was a special name for these type of angles.
vertical.
They're vertical angles. Thank you. That's what I was looking for. Okay, these are vertical angles. Okay. How am I going to find Z and Y now? First off, what does this mean? If this line has one dash and this line has one dash, then these lines are equal. So guess what? If those lines are equal, then these angles are equal. Okay, so this is also Z. This is an isosceles triangle where two sides are the same. So, what do we know about the measure of the inside angles of a triangle? What's the total of these angles have to be inside of a triangle?
90.
Huh?
Is it 90?
180.
180. The angles inside of a triangle are 180 degrees. So if this angle's 28, we can take 180 minus 28, and that gives us what measurements left over. So 152. Okay. There's 152 degrees left over in this triangle. Well, if these two angles are the same, how do we find the measure of it?
Divided by 2.
Divided by 2. So each one of those angles, Z is 76. Bless you. Bless you.
Thank you.
Okay, same situation over here. X is 28. These two sides are the same. So Y and Y. So Y is also equal to 76 degrees. Okay. All right. Hopping over to this side of the paper. We're going to be able to solve for unknowns with similar figures. So we've got a 6 foot tall tent. Okay, so our tent is 6 foot tall. I always like to draw pictures. My tent is 6 foot tall and it casts a 9 foot shadow. Okay. My tent is 6 foot tall and it casts a 9 foot long shadow. Then we've got this box. We don't know how tall the box is, but we know that it also casts a 6 foot shadow. We need to find how tall the box is. So we're going to set up a proportion just like we did in the last problem. So height over shadow, 6 over 9 equals. If I do 6 over 9 in the first one, what do I have to do for my second fraction?
X over 6.
X over 6. Again, I have to do, if this is height over length, this has to be height over length. So X over 6.
Cross multiply.
Cross multiply, so 9 times X is 9X. 6 times 6 is 36. And my last step is going to be
Divide by 9.
divide by 9.
4.
X is 4. So my box is 4 feet tall.
Flip
It
it.
depend, does it depend on what the question asks you, but like, what you have to do?
Mm-hmm. Because it says how tall is the box. So that's what we're looking for. And everything's in feet, so we have to keep that in feet.
And the other one was asking us like, are they equal?
You weren't solving for anything, they just wanted you to prove that they were similar. Okay. A telephone booth is 8 feet tall and casts a shadow that is 4 feet long. So we've got a telephone booth, it's 8 feet tall, and it's got a 4-foot shadow. Find the height of a lawn gnome. So I need to know the height of this lawn gnome that casts a 2-foot shadow. I'm going to switch it up on you. So I'm going to do 4 over 8 this time. If I do 4 over 8, my second fraction has to be 2 over x. Okay? So it doesn't matter what order you put the first fraction in, you just have to make sure that it matches in the second one. So we've got 4 times x
4x.
and 8 times 2,
Oh,
16. Then we do what, Elijah? How do I get x by itself? You have to do opposite of what's here. So we divide. So x equals 4. So our lawn gnome is 4 feet tall. Not too bad, right? A man has a scale, or I'm sorry, yeah, a man. A map has a scale of 3 centimeters equals 18 kilometers. Okay? If Riverside and Smithville are 54 kilometers apart in real life, how far apart will they be on the map? Okay, so your first fraction comes from your scale factor, 3 over 18. Where does 54 go in the second fraction? Top or bottom? Bottom, good. If kilometers are in the bottom over here, kilometers must be in the bottom over here, which means I'm solving for the top. Cross multiply, you get 18x equals, is that 162? Okay, divide by 18. What does x equal?
No.
So they are 9 centimeters apart on the map. If they're 54 kilometers apart in real life, they are 9 centimeters apart on the map. A model house is 12 centimeters wide. If it was built with a scale of 3 centimeters is 4 meters, then how wide is the real house? So I've got 3 to 4, that's my scale factor. What does my fraction look like on the other side?
12x.
12 over x, good. Centimeters on top, meters on the bottom. So we get 3x equals 48. Divide by 3, so x is going to equal
9.
how many times does 3 go into 4? 16. Okay. 16. So it's 16 meters in real life. Questions or problems? Okay. You can cut out both of those, and they're going to glue in on pages 87 and 88. We will, by the end of this week, be into your next notebook, so please make sure you get your second notebook.
Take your bathroom.
Don't forget too, if your name is over there for a missed test or quiz, you're eating a 0 right now, which is bringing your grade down. You need to come make those up after school. You will not have class time to do it. I am literally teaching till the day of your final. We have no free days, no review days, no nothing.
You said 87 and 88?
Yes, ma'am. Okay, and I have 10 problems that we're going to practice with. And then you have a homework worksheet that goes exactly with this worksheet. So you should have plenty of time to work on your homework. If you finish, you may turn it into me early so I can get it graded. If you finish it early, I want you working on your project. This is why our lessons have been so short. I want to give you guys time in class to work on your project. That way, if you have questions, you can ask me. Please draw me out a rough sketch of what you want yours to look like and bring it to me so I can make sure that everything's in the correct position. You do not want to be losing points for things that aren't in the right places. Especially when you have every opportunity to ask me to begin with. Okay, it states clearly that these are similar figures. They want you to find the value of the variable and round it to the nearest tenth where necessary. If I'm looking for the nearest tenth, how many places after the decimal is that? The tenths place is how many places after the decimal? 1. Good. 1. Okay. So, somebody set me up my first fraction.
20 over 32.
20 over 32. Okay. If my first one is 20 over 32, my second one, Barley, should look like what?
X.
Perfect. X over 8. When I cross multiply, you get 32x equals 160. Divide by 32 and we get what? Okay, take a look at number 2. Travis, set me up my first fraction.
1730. Well,
It has to either be from this rectangle or this rectangle.
30 over.
30 over p. Okay, our variable's p this time, so 30 over p, which means, Janiyah, my second fraction should look like what?
17.
Over p,
12 over 16.
so it has to be 12 over 17. So we get 12p equals
510.
510.
Yeah.
Divide by 12.
42.5.
42.5. Okay. And we're going to leave that because it says to round to the nearest 10. Okay. Number 3. John, set me up my first fraction.
And over 81.
N over 81, which means my second fraction should look like what, Anna?
28 over 60.
Perfect. 28 over 63. So you get 63n equals
2,227. Oh, 28. I mean 68.
2,268.
Yeah.
Okay. Divide both sides by 63. N equals 36. Perfect. Okay. Do not get caught up with the second one because there's 2 variables we need to solve for now. I need to solve for E and I need to solve for F. Okay? E is associated with this side, F is associated with this side. So this is the fraction that we're going to use to solve for both. Okay? So we're going to do 8 over E. Okay? We have to use these numbers because they're the only ones that aren't associated with a variable. So 8 over E is going to look like what over what?
6 over 16.
6 over 16. So you get 6E equals 128. And divide both sides by 6.
$21.3.
21.3 repeating. Okay, remember when it repeats 3, 3, 3, 3, 3, you put that little line over top of the 3 to show that it's repeating over and over and over again. Okay, now I need to solve for F. So I need to do 8 over 21. And that's going to equal what over what?
6 over F.
6 over F. So 8F equals 126. Divide by 8. Okay, it says round to the nearest 10, so it's going to be 15.8.
Oh, 8.
Okay. It's 15.75. That 5 rounds your 7 up to an 8. Perfect. Okay, one more on this page. Word problem. Okay, it looks just like the pictures we did on those 4 problems before. A meter stick. Okay, we've got this meter stick. It casts a shadow that's 14 meters long. Okay. So their shadow is 14 meters or 1.4 meters, sorry. And the flagpole here is casting a shadow that's 7.7 meters long. Okay. They want us to find the length of the flagpole. How tall is that flagpole? Well, how tall is this? This is not a trick question.
4. No, 1.4.
No.
No?
It gives a 1.4 meter shadow.
That's gotta be another variable. I mean, no.
It's not a variable.
Is it half of?
Read your question again. A what stick?
A meter stick.
A meter stick. So that means this is 1 meter. It's a meter stick. It's a meter long.
Oh, that makes sense.
That's what I said. It is a trick question, but it's not a trick question. Okay. So I can do x over 7.7 equals, what does my second fraction look like, Elijah? If I do x over 7.7, it has to look like, don't shrug your shoulders at me, you're going to answer this. If this is x over 7.7, my second fraction has to look like what? I did height over length. So my second fraction has to be, it's coming from here. Elijah, I'm not letting this go. We're going to sit here until you can concentrate and figure this out.
6 years.
If this is x, which is the height of the pool, over 7.7 meters, which is the length of the shadow, this has to be, what's the height over here? 1 meter. What's the length of my shadow over here? 1.4. Okay. We cross multiply to solve. 1.4x equals 7.7 divided by 1.4. And x is going to equal what?
5.5.
5.5. Perfect. And this should be in meters. Everything's in meters. Don't forget word problems when they give you meters, centimeters, inches, you should use them. Okay? All right, other side. This is going to kind of be like the one on the left-hand side that we did. Tell whether the figures are similar and justify your answer. Again, if you can prove that your proportions are equal, you can prove the figures similar. Okay, these are two rectangles. So if this side's 18, what's this side? 18. If this side is 36, what's this side? 36. Okay, so I can do 18 over 36 equals, I did the short side of my rectangle over the long side of my rectangle. So my other one should look like what?
25 over 45.
25 over 45. Cross multiply and see if it works. So we've got 36 times 25. That equals 900. What do you get when you take 18 times 45?
810.
810. Are they equal?
No.
No, not similar. Where it says justify your answer, this math work that you just did is justification. You just proved it through math, just not through words. Okay. Number 7. Okay. We have to be careful what we use now. So let me do 16 over 30 for my first one. If I do 16 over 30, what do you think I have to do in the second one?
8 over 15.
Perfect. 8 over 15. Okay, let me explain why. Okay, everybody's eyes up here. 16 is across from my 30-degree angle. So I have to go over here. Across from my 30-degree angle is my 8. That's why 8 goes on top. 30 is across from 60. Across from my 60 is 15. Okay.
Well, so what happened, you know, when that 30 is at the bottom on the outside between P and not the like
Right, you're using
Yeah.
this 30.
what happened if that was different from that the one on the inside?
Like this,
Yeah, they always go with the
it had no. This could be 7.
Yeah, I know. What I said, what is different? It's still gonna be 30.
Not necessarily. This is a special right triangle. It's a 30, 60, 90 triangle. Don't even worry about the degrees right now. What you're doing with the degrees right now is being able to identify what sides go with what. Okay, so your 16 goes with your 8 because they're both across from your 30-degree angle. Your 30 goes with your 15 because they're both across from the 60-degree angle. Okay, so don't worry about the inside angles yet. That will be the entire next unit. We're going to look at that. Okay, so let's prove 8 times 30 is 240. What's 16 times 15?
240.
Okay. The hard part about triangles, though, is you have to prove that all 3 sides are similar. I can't stop here. Okay, so I compared 16 to 30. I've got to do 16 and 34 and make sure they work. If I do 16 and 34, again, 16's across from my 30-degree angle, so I have to start with what? 8 over 17 this time. 17's my hypotenuse, 34 was my hypotenuse. So we need to try this one now. So we're doing 16 times 17. And you get 272. What's 34 times 8?
The same thing.
The same thing, 272. I hate to do this to you, but we've got to check one more. Okay, we did 16 and 30, 16 and 34. Now we've got to do 30 and 34. You have to do all 3 sides. That's the hard part about triangles. Unless they don't give you all 3 sides, then you don't have to.
15 and 17.
Okay, so you said 30 and 34, and we're doing 15 and 17. Perfect. So we got 34 times 15, which is 510. And 30 times 17 is what?
The same thing.
Same thing. Okay, all 3 of them check. Yes, these are similar.
I have a question.
Yes.
What if one of the sides wasn't equal to each other?
Then it's not similar.
Oh.
And that has happened, which is why I tell you to check every side that is available to you. Okay. Let me do 14 and 8. That's going to equal what? 49 over 28. Okay, so we've got 8 times 49, which is 392.
It's the same thing.
It's the same thing? Perfect. 392, so yes, these are similar. You can stop here on this one even though they're triangles because of the fact that that's all the information they gave you. Okay, there's nothing else to compare.
So we don't need to look for the for
There's nothing else here.
Oh.
Okay. So you can't do anything else. Okay. Given that line ST is parallel to DE. Okay, so this line and this line are parallel. They want us to find angle X. Okay, well, tell me this. This side and this side are the same, correct? So what does that mean about this angle and this angle? They're the same. This is an isosceles triangle again. Okay? We know that this angle is 82, and all of the measure of the inside of the angles are equal to what? 180. So x plus 82 equals 180. We combine like terms, 2x plus 82 equals 180. Travis, what's my next step here? I've got 2x plus 82 equals 180. I got to get x by itself. So how do I get rid of this?
Lot of 6.
This is plus 82. What's opposite of adding? Minus. So we subtract 82 from both sides. 2x is 98. Divide by 2. X equals 49. Perfect. Last one. Old Faithful. Who's heard of Yellowstone National Forest? And they got the big geyser, Old Faithful. Okay, it shoots water 60 feet into the air that casts a shadow of 42 feet. Okay, so here's Old Faithful. They've marked that it's 60 feet. Okay, I'm going to zoom in on this picture here. Okay. Old Faithful shoots 60 feet in the air and casts a shadow that's 42 feet long. What is the height of this nearby tree if it casts a shadow that's 63 feet long? So I'm going to do 63 over x. What does that equal? 42 over 60. Okay. When I cross multiply, I get 42x equals 3,780. Divide by 42. What does x equal this time? 90 what?
90 feet. Wait, what?
Okay, everything's in feet, so that should be 90 feet. If you go ahead and cut this in half, it's going to go on 89 and 90. While you're doing that, I will get your homework out and start passing it out. There are there's 10 questions on this as well. You have plenty of time to get started.